Good day everybody. So, my name is Sourav Mukhopadhyay. I am an associate professor at Department of Mathematics, Indian Institute of Technology, Kharagpur. So, I welcome you all to this course Introduction to Abstract and Linear Algebra. So, this is a very fundamental course on abstract and linear algebra. So, first we start with the set theory in this course. So, what is the set, and then we talk about set operations, union, intersection, then we will move to the set relations, mappings. So, then we talk about different type of mappings like bijective mapping, onto mapping. So, all these things we will cover under the set theory. Then we move to the algebraic structure like group. We define the group, and before that we have to define a binary operator, binary composition, which is basically a mapping. And then we move to the algebraic structure like group, ring, field, and then finite field, some of the applications of the field, finite field. And then we move to the vector spaces, that is the part of the linear algebra. So, vector spaces, then we talk about, we define what do we mean by vector spaces, then we talk about linear transformation over the vector spaces, then we introduce the matrix, then how this matrix is related with the vector spaces. So, in the vector spaces we talk about basis, we talk about dimension of a vector space. Okay, so, all these basic details we will cover under the linear algebra part. Then we finally move to the some of the advanced topic on abstract and linear algebra. So, there we discuss some of the application of both abstract and linear algebra. Okay, so, again I welcome you all to the course Introduction to Abstract and Linear Algebra. So, this is a 8-week course, and each week at the end of each week there will be 5 modules. Each module is around 25 to 30 minutes. So, at the end of each week there will be a online assignment, and assignment will be MCQ. You have to submit the assignment, and then after the 8 weeks the course is over, there will be exam, and again exam will be online. So, it will be again MCQ based. So, you have to give the online exam. So, and then you will get the so, exam is not mandatory for this course, attending this course, but those who want to get the certificate, they have to register for the exam, and they have to sit for the exam and get the, after passing the exam they will get the certificate. Okay, so, let us start with the set theory. So, we start with the definition of the set. So, what is a set? Set is basically a well defined collection of distinct objects. Set is well defined collection of distinct objects. Okay. So, this is the definition of the set. So, there are few terms, few keywords are involved here. Like one term is, it is basically a collection. It is a collection of objects. These objects are also called elements. So, these are the and there is another term well defined. So, what do you mean by well defined? We will explain. And there is a term distinct. So, set should not contain equal elements. Set is a distinct collection of object. For example, if we take a set like, and set are represented by a symbolically we denote this set by capital word like A, B, C, D. So, these are the capital letter alphabet are used to represent a I mean set. Like if we define a set A, which is the first 4 natural number, like 1, 2, 3, 4. This is a set. Okay, this is a collection. We take a bag and we put this number into that bag. That is a collection. Any collection. This is a collection. So, this collection is a set. Now, we have to take these other properties like distinct. This is a distinct collection. There is no repetition, but if you take this set, say 1, 2, 2, 3, 4, 4, 5. If you take this collection, this is not a set, because this is not a distinct collection, because 4 are repeating 2 times, 2 are repeating 2 times. So, this is not a distinct collection. So, set has to be distinct collection, there will be no repetition of the elements in the set. Okay, so, this is one property of this collection, and another property is the well defined property. Well defined property means once we declare a set, that means this is a set. What is the properties of this set? That it is the first 4 natural number. Natural number means 1, 2, 3, 4, 5, 6 like this. So, it is first 4 natural number, that is 1, 2, 3, 4. Now, well defined means if we take any other object, and these are the elements, these are called objects, or these are the objects, or one object, this object, or it is also called element. This is basically member of the set. Now, if you take any other object, say if we take 5, a natural number 5, then if we ask whether 5 belongs to this set A or not, the answer will be yes or no, straight cut. It is not that maybe, may not be, not like that. Is 5 belongs to A? No. 5 does not belongs to the set A. This is the property. I mean, this is the well defined property. If you take any other object from universe, like me, Sourav, is Sourav belongs to this set? No, straight cut answer. But it is the natural number 4 belongs to this set? Yes. So, 4 belongs to this set. This symbol is used for belongs to. This is the notation. This is the notation we use for belongs to. So, 4 belongs to this set. So, this is the property, and this 5 does not belongs to, this is the does not belongs to symbol. 5 does not belongs to A, even me, Sourav does not belongs to this set. So, this is called well defined property. If you take any object from the universe, we will define the universe, then we can say, we can straight away able to say whether that object belongs to this set or not. Okay. So, this collection, this well defined collection is called a set. Now, if we define a set of all people belongs to this room. My set is, say S is a set, this is set of all people in this room, in this room. Okay. Now, if this is my set, S set, so this may be I am Sourav, then you are Jiten, you are Palash, okay, and so on. So, this is my set now. Okay, what is my set? My set is the set of all human beings in this room. Now, this is distinct. I take this collection as a distinct collection. I am not repeating Sourav twice or Jiten twice, and this is well defined. Well defined means, if I say, if I take a person, say Bimal, who is not in this room, then we can say that Bimal does not belongs to this set. But if you take Jiten, then then we can say, okay, Jiten belongs to this set or not. If we say natural number 10, is this natural number 10 belongs to this set? No, natural number 10 does not belongs to this set. So, this is called well defined property of a set. Okay. So, this is the definition of a set. Now, we talk about how we represent a set, how to represent a set. Okay. How we can represent a set. Say for example, if we have a set like this, so every set has a property. Say our set is first 4 natural numbers, that is a property. So, 1, 2, 3, 4. We can explicit, this is the explicit way to write a set. We mention all the elements of that set in this collection. So, that is one way to represent a set. Explicitly we write, but if we say that my set is all the human beings in this room. So, that is all the people here, say there are say how many, around 30-40 people. So, you can just write the name of the people like this, and we can explicitly write all the names of 40 people, and this collection is a set. So, this is one way to represent a set explicitly, but this way we have a issue with the size of this collection. Like if we have 100 people in this room, then this set has to, we have to write 100 names in this collection. So, this is if we have more, if we have infinite number of, like if we have a set of natural number which is denoted by n, this is say 1, 2, 3, 4, 5. So, it is not possible to explicitly write all these elements. So, what we do? We just write a shortcut, I mean we just write in a different way, like this set. This is a x, x is a human being, x is a human, and then x satisfy property. What is property? X is in this room, x is in, x belongs to this room. Okay. So, this is the way we represent this set. So, this is the property x must satisfy. Okay. So, that means any set we can write in this way, x follows some properties, x follows p, the property, this is a property. So, for this set this is a property. What is the property? Property is this person is belongs to this room, that is the property. Okay. Now, if you take the set of integers, so set of integers, so this is the n which is the set of integer. Now, if you take the set of even integer, not only integer, natural number. So, this is x, x belongs to n and x is even. So, this represents the set of all natural even natural number, like 2, 4, 6, 8, 10 dot like this. Okay. This is the set of even natural number. So, every set has a property, we denote that set and followed by the property. Okay. So, now we just talk about, we just define some set which are very standard set notation, like set of, as we said, n is represented as set of natural number. natural numbers. So, n is basically starting from 1, 2, 3, 4 dot 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 dot. Okay. Then we represent Z. Z is the set of all integers. These are standard notation we will use throughout our course. Set of integers, like it's positive integer and negative integer also. So, we have starting from minus infinity, then we have dot 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 say minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4 like this. Okay. So, this is the set of integers, and then we have the set of positive integer, and then we have rational number q. Q is the set of rational number. So, what is a rational number? Rational number is a number which can be represented as p by q form, where p, q are both integers. So, it is basically a real number, real number set is R, such that x will be written in the form of p by q, where p, q are coming from integer set Z. Okay. So, this is the property that p, q, there must exist p, q such that. So, every integer or every natural number is a rational number, but not all, like this is a rational, 3 is a rational number, 3 by 2 is a rational number. So, what is the not rational number, which is called irrational number? We know that root 2 is an irrational number, because for root 2 there is no such p, q will exist. Root 2 cannot be written as p by q form. So, this is the notation, standard notation, and there is a set of real number which is R, and the set of positive real number we denote by R plus. So, these are the, so R is the basically set of the real numbers. Okay. And R plus is the set of positive real number, positive real numbers, and we can define another set of complex numbers. So, there are many others, whenever it will come we will just define at that time. This is the set of complex number. Okay. So, whenever the notion will come, we will discuss that time. Okay, now we defined a set which does not contain any element. This is the convention to define such a set. So, that is called empty set. Empty set, which is basically a set having no element. So, this is denoted by phi, set containing no elements. Okay. So, this is called empty set, this is null or empty set, null set, sometimes it is called null set also. Okay. Then we define another set which is universal set, which is denoted by E. This is basically set of all universe, like it is very relative things. Like if we say we can define our universe, suppose we are dealing with the numbers. We are dealing with the numbers, then we can set our universe to be R. We can set that. Then we can talk about, we are in number system, real number system, then our universe is R. Then we any set, any element, then any real number or any integer, any natural number belongs to this set. So, this is the universe. Now, if we in a complex plane, then our universe is a complex number, or if you are talking about the living elements. So, our universe could be all the living elements in this world, that is the universe. So, we can, so universe is very relative thing. So, universe we can define depending on our applications. Okay. Universe is basically set of all sets, like we will define the subset. So, every set is a subset of this universe. Okay. Now, let us define the subset, it will be more clear. Okay. So, subset, so what is the definition of subset? Suppose we have two set A B. So, we say A is a subset of B, this is the notation to use, subset notation. So, we say A is a subset of B if and only if we take any element x from A, this implies x will be in B. So, that means every element of A is an element of B. If that property satisfy, then I call A is a subset of B. We take any element. So, this is for any element, any element x belongs to A imply this, or in other word we can say an element x belongs to A if it is imply x belongs to B, and this is, if this is for all, this is the symbol we use for all. If this property satisfy, then we called A is a subset of B. So, we take an element, arbitrary element in A, if we can show this is an element of B, then that is sufficient to say A is a subset of B, any element. So, every element has to, every element of A must be a member of element of B, then A is a subset of B. Now, this symbol is includes, so if we use only this, like if we, this is a proper subset symbol. So, A is a proper subset of B. Proper subset means, so there is an element in B which is not in A. So, that means B is bigger than A in that sense. So, again bigger and smaller is relative to the cardinality of the set, we will come to that. So, every proper, this is a proper subset. Proper subset means A is a subset of B, but if there is a element, there has to be at least one element y belongs to B such that y does not belongs to A. Okay. So, then we call proper subset of B. Now, we have some properties of this. Now, every this empty set is a subset of every set. Okay, this is for all A. So, every set A, this is, but this is a proper subset. If A is not empty, then this is a proper subset. Okay. And then if we have A which is subset of B, then B is called superset of A. Like if A is a subset of B, then this means A is a subset of B, and in other word this is also called B is a superset of B is a superset of A. So, these are the definition of subset and superset. Okay. And so, if we define the universe set, so every set is a subset of a universe set, universal set. Every set is a subset of the universal set. So, if we take a set A, this will be the subset of universal set. So, this is true for every set. Okay. So, this is just a introduction and the definition of the set, and in the next class we will talk about we will start the set operation like union, intersection, and then we will define those operations, and then we will discuss some properties on these operations, and we will prove those properties in this way. So, that we will discuss in the next class. Thank you.